This conference will now be recorded.
Yeah. In today's session, we're going to discuss about what is generators in Python. If I want to iterate some values from my list, what I will do, I will use the iter function that will converse that will return as an iterator. That function is going to return as an iterator. I want to iterate one element at a time. By using next function, I can get the values one at a time. Okay. Now, if I want to iterate the values using generator, mostly for iteration uses generators. If I want to iterate some values, I can use generators. When compared to iterators, generators has having various advantages. Now, we're going to see, for example, I'm going to generate a sequence of values. For this, what I'm going to do, I'm going to create a py file, new Python file. In that, I'm going to make generators using Python as a py file. Before going to generators, I'm going to create a normal function. Normal function. I'm going to create an addition function. In that addition function, I'm going to pass two values, a comma b colon. I'm going to add some values c equal to a plus b, and then I'm going to use the return statement. Finally, I'm going to give a c. If any of the caller means if anyone going to call this method, what will happen? It's going to add the two numbers and then finally going to produce some sum, and then the sum is going to store in the memory. It is going to store in the memory. Just take one more method. Def I'm going to have one list, iter of list. In that I'm going to pass one. I'm going to have one list lst equal to 1 comma 23 comma 45 comma 67 comma 89 and then 90, and then if some of the caller call this iter list method, I going to return this list. This entire element will be stored in the memory. Now I have six elements. I have these six elements, it can store memory. Just take 1 lakh elements. If I store everything in memory, what will happen? For example, I have 1 lakh values. If I store all the 1 lakh values, memory is not efficient. Memory is not efficient. If I want to do some streaming, I want to stream the log files, everything I can't place in the memory. I can place only one file at a time in the memory. For example, I have 1,000 log files. I want to process 1,000 log files. If I keep all 1,000 files in memory, the memory is not that much efficient actually. What I want to do, out of 1,000 files, I want to keep only one file memory. After processing, what I have to do, I have to take the second file and then I want to keep in memory, and then I have to process, and then I want to take the third file. Okay, if I want to perform this kind of streaming operations, don't go for a normal function. In normal function, we have a return keyword. The return keyword is you can iterate all the elements and then you're going to have all those elements in memory. We can't say memory is not efficient. Memory is not that much efficient because you're going to have all the values. For streaming, I have 1,000 files. You're going to keep all those in memory. Okay, memory is not that much sufficient actually. Okay, you want to utilize memory properly. For that, instead of creating normal function, better create a generator object. Now I'm going to talk about the generator object. You might have a question how to create a generator object. Yeah, I'm going to say now. I'm going to same method. See here, I'm going to same method. Def. I'm going to have iter values. It's a method name. Put colon. I'm going to use yield keyword. Instead of return, what I'm going to use? I'm going to use yield keyword. In a normal function, you can use only one return statement that will do all the processing. Finally, it will going to return the final result. It will iterate all the values and going to return a final output in the return statement. But in the generator object, if you want to create a generator object, definitely you have to use yield keyword. This yield keyword will generate a generator object. Now, what I'm going to do? I can use n number of yield. You might be wondering what is yield going to do. Now, I have this method. Method name is iter values. Just reformat this file. Now, I'm going to have my driver code. If name, I'm comparing. If my name is main module, if my name is main module, I'm going to call this method. What's the method name? Iter values. Okay, I'm going to call this method. How am I going to call this method in the sense? Next of iter values. This yield keyword is going to create a generator object if some of the caller, this is a caller actually, some of the caller calls this method, what will happen? It will return the state. It will return the state. What state now belongs to it? The value is 1. It won't process this 16th line and 17th line. It will going to process only this state now. Temporarily we are storing this value in the generator object. If I give next of iter values, it's going to give only, oh, I have not used print statement. Just use one print statement over here. Then only you can see the console. If I put print next of iter values, I'm going to get 1. What is happening here? Generate object. This yield function is going to generate a generator object. If some of the caller calls this method, what will happen? It's going to return the state of this value. It's going to pass the remaining statements. It's going to pass the remaining statement. It's not going to give 2 or 3. If again the caller calls the same method, it's going to return this state. Now the value will be, for this next iter values I'm going to get 1. For this next iter values I'm going to get 2. Hold a minute. Why it's not getting 2 over here? Iter of next iter of values, it should be 2, right? Why it's not getting 2? Hold a minute. 1 1. Why I'm getting 1 1? Okay, got it. It's returning only one state actually. It's getting iter of values 1 1 1. Why I made a mistake? Okay, hold a minute. Wild of 2, yield of 3. Now, what I going to perform? First, I calling the next. Okay. I made a blunder mistake over here. What I have to do? After creating this iter value function, I have the yield 1, yield 2 and yield 3. Okay. what I have to do, I have to create, I want to assign into one variable, assign into one variable. Now what I going to do, I going to call this variable x. I have to use next of x. If I run this code, it's going, this caller is going to call this method, it's going to return the state. The state will be 1. What it's going to do, after returning the state, present state, it's going to pass the, it's going to pass the remaining states. It's going to pass the remaining states. Now if someone calls again next of x, what will happen? Actually now the state is passed, right? It's going to resume now. It's going to resume from the state. Now it's going to print the value as 2. Now next line will be passed. Okay, if the caller calls this method again, what will happen? Next of x, from the state, what will happen? It will resume, and then it's going to print the value as 3. In this memory, what I'm trying to conclude over here is, it's going to have a single element in the memory at a time. Okay, if I want to create some generator object, I have to use a yield keyword. If some of the caller calls my method, what will happen? It's going to give the present state. It's going to give the present state. After this, second statement will be passed. It is not going to execute the yield 2 or yield 3 not going to execute. If the caller again calls the next of x, what will happen? Again you're going to call this method. Okay, now from second statement is passed, right? Now what will happen? It's going to resume, and then I going to give the second state as output as 2. Now after giving the output as second stage, third stage will be passed. If again the caller calls this method, what will happen? The pass stage will be again resumed. Sorry, again it will be resumed. This state will be printed as an output of 3. Okay.
This conference will now be recorded.
Okay. Now I'm trying to add the yield of 4. Okay. If a caller calls this method, then the statement will be resumed. It's going to print the current state output. The output will be 4. Now what I going to do, I going to generate one Fibonacci series. Fibonacci series. For this I going to get the function. The function name is Fibo. Okay, and then I going to use the chained variables. Variable name is AB. A value is 0, B value is 1. A value is 0, B value is 1. Now what I going to do? Yield of A. Yield of A. Yield of A means if someone calls this method, what will happen? The A value will be printed. The A value will be printed. Okay, fine. Now A comma B equal to B comma A plus B. I will take one notepad. I have two variables 0 and 1. If I add 0 and 1, what output will get? 1. 1 plus 1, output is 2. 2 plus 1, output is 3. 3 plus 2, output is 5. This is how the Fibonacci series will be generated. You have to add the previous value and current value. Okay, previous value and current value you have to add for generated output. 5 plus 3, 8. 8 plus 5, 13. This is how I am going to generate my Fibonacci series. Now, I took two chained variables, a comma b equal to a value 0, b value is 1. A value is 0, b value is 1. Okay. Okay. A value is 0, b value is 1. And then I am going to pass yield of a. If someone calls this method in 20, it will process up to the only 20th line. It will process up to only the 20th line. 26th line will not be processed because this yield function is going to return a generator object. It's going to return the only current state value. If someone calls the method again, then only what will happen? This statement will be resumed. The statement will be resumed until it will be passed. If the call is not calling method again, this statement will be passed. If again the call is calling this method, then only it can able to evaluate these expressions. Okay, this is how you can do in the Fibonacci series. What I can do in Fibonacci series? I generate Fibonacci series. Yeah, what I can do, I can pass some. I want to pass some values, right? I want to pass some values. What you can do, you can pass some values. Num you can pass the argument you can pass, and then I going to use one while loop over here because I want to generate the Fibonacci series in sequence, right? For this, I going to use one while loop. While a less than num, okay. As per the indentation, you have to give the proper indentation, and then do a plus a comma b equal to b comma a plus b. Now I going to create a generator object. Okay, how will create a generator object? If any of the function is having yield, then we can able to create a generator object. I going to take the variables y equal to Fibo. I going to pass the number value is 5. Okay, the number value is 5. Sorry, number value is 5. Now, what I going to do? I going to use a print statement. I going to pass the value of next of y. If some other caller calling my object, okay, the calling my object is y. What will happen? It's going to call this method, and then up to this line will be executed. The 27th line will not be executed because the statement will be passed. Okay, now you're going to see the output. If I call next of y, what is my output? If I call next of y, what's the output? Just pass 5 over here, and then you have to check a value 0, 0 less than 5. The condition is satisfied, and then it's going to give the yield value as 0. Yield value is 0. Hold a minute. Yeah, I want to just make generation of Fibonacci series. Okay, now run your code. Okay, where I made, okay, hold a minute. What I did right, I want to take the entire thing, then paste it below. Now you can see the output. It's giving 0 value. What's the next value? We pass next of y, what will happen? This statement will be resumed. Now, what's my a value? Can you say? What's my a value?
1.
The b value will be 1, right? The b value will be 1. Now the a value is going to be 1 because I want to substitute. I given a comma b as well as the b value will be assigned to a. Now the a value is 1. What about the b value? B equal to a plus b. A value is 0. B value is 1. Now a value is 1 and b value is 1. What happens if I call next of y? It's going to resume. It's going to resume this line and then it's going to perform these calculations. Afterwards, it's going to come to the again the while loop. The while loop again going to check the condition. Now the a value is 1. 1 less than 5 because I given the number as 5, right? 1 less than 5 and then it will stop here. It will stop here. What's the yield a of value? Here will be 1. You can see. Now, if I give next of y, what will happen? Again, this line will be resumed. Previously it's passed, right? Previously it was passed. Now, if I use print next of y, this line will resume. Now, what's the a value? What's the a value actually?
1.
1. What's the b value? B value is a plus b. Already a is 1, right? 1 plus 1.
Already 1.
Already 1. B equal to, you have to see b equal to a plus b. Now the b value is 2, right? B value is 2. Okay. Now, after executing this line, again you will go to this function, and then it will take the a value is 1, b value is 2. Again check for condition. 1 less than 5. The condition is satisfied. Now, what's the yield of a value? 1 less than 5. Again yield of a. What's a value? 1. Again is going to print 1 only. You can see. If you are not clear, you can see the output.
Okay.
0 plus 1, 1. And then 1 plus 1, 2. 2 plus 3, 5. Okay. You have to add the previous value as well as current value you have to add to generate the next output. This is how Fibonacci works. Now, if I call again print of next of y, what will happen? What will happen? This statement will be resumed after the yield. The statement will be resumed. Now the b value will be 2. I have to assign to a. Now the a value is going to be 2. B value is going to be 2 plus 1, 3. 3. Now again, what will happen after resuming? This line is going to execute. Again, is going to go for this while loop. It will check for a condition. Now 2 less than 5. The boolean value will be true, and then it's going to give the yield of a. What's the a value now? 2. Okay, the a value will be 2. This is how the generator object will work. Okay, whenever you are using yield keyword instead of return statement, it's going to return only the current state of that variable. Okay, it's not going to keep all the values in the memory. If I use return keyword, it's going to have the list of values in memory. That will not be a memory efficient. Better go for huge number of values in the list. Better go for generator object. If you want to create a generator object, definitely you should have a yield keyword. That yield keyword will have able to handle only one element at a time. It won't take a huge values memory and then you want to process anything. Okay, it will take one by one values and process at a time. Okay, now instead of doing all these things, what you can do, you can use for loop. Okay, see how I'm going to do. I'm going to remove all these things. I'm going to comment this thing as of now. Instead of next statement, what you can do, you can use the for loop. For I in directly can call the Fibo method. Fibo of this we are going to pass the number value as 10. Just print the value. Print the value of I. Now it's going to generate for a sequence of 10. For a sequence of 10. You can see first 0, 1, 0 plus 1, 1. And then 1 plus 1, 2. 2 plus 1, 3. 3 plus 2, 5. 5 plus 3, 8. Okay, like this you can generate for Fibonacci value 10. You can generate like this. You can generate for 20. You might have a question. Okay, why I have not used next? This next function, first you want to convert into a iterable. That iter function is going to return an iterator. From an iterator, I'm going to access element one by one at a time. Okay, if anything you using iterator, then you can able to use the next function. You can able to get the elements one at a time. But in for loop, we have a inbuilt iterator. Already said to you, in for loop we have an iter, and then next function we have internally. Okay, directly without the need of next function, you can able to iterate the values one by one at a time. This I won't say the variable. It's a iter variable. It's a iter variable. I'm going to print all the values 0, 1, 1, 2, 3, 5, 8, 39. I can able to print. Okay, this is how the generator object will work. Now I will take one more example. What I can take. Okay, I will take one counter. Have one py file. Counter using generator. Using generator. I'm going to have one method, my generator. Now I'm going to initialize one variable value equal to 0. Now you going to see the result for me. I'm going to use a while loop. In my generator function, I'm going to pass limit as your argument. Now what I'm going to do, I'm going to check for condition value lesser than limit. Till then my while loop will be keep on executing. I'm going to create one generator function with the help of which keyword? Yield keyword. I'm going to have the value yield value going to get. After yield statement, I'm going to give what I'm going to give value plus equal to 1. Now what I'm going to do, I'm going to create a generator object. Have a command line, create a generator object. Okay, I'm going to have the variable m equal to my generator, and the limit I'm going to pass 5. I'm going to the print statement next of m. Now you're going to say what is the value I'm going to get. I create a generator object, okay, with the help of yield keyword. Now if I pass next of m, what output is going to give. Now which line number will be passed? Now which line number will be passed? You have to say. What is the output for the first state? What is the output for first state?
1.
Or you can say it's current state. What's the value? Just pass the value 5 in the limit. Now the limit value is 5. And then check for the condition 0 lesser than 5.
Yes.
And then I'm going to give the yield value as value 0, 0 less than 5. And then yield values I'm going to print 0. Yield value will be 0. Okay. Now, hold a minute. Now, if I call the statement, the same statement again, what will happen?
1.
Yeah, what will happen, right? It is going to resume the statement. Okay, after the yield keyword, the control automatically is going to resume. Okay, previously it was passed. Now it's going to resume. Okay, now value equal to value plus 1. The previous value was 0. 0 plus 1, 1, right? Again, it will go to the while loop. 1 lesser than 5. The condition satisfied, and then it's going to give the yield value will be 1. Okay, I think you have understood this logic. If I call the statement again, what will happen?
2. 1 plus 1.
Yeah, again what will happen? This line will be resumed. Okay, previously it was passed. Now the state will be resumed, and then value will be already value previous value is 1, 1 plus 1, 2, and then it go for the while loop, and then check 2 less than 5, and then now the yield value will be 2. You can able to see, right? 0, 1, 2. Okay. Instead of calling this next statement multiple times, what we can do? What we can do? Directly you can use for loop. In for loop, we have a iterator object that is going to iterate the values one by one at a time. Directly you can use for I in my generator. You can pass some limits 12 and then print the value of I. You can able to see it's going to generate 0 to 11 because I given the limit as 12. You have to make n minus 1 because we are considering 0. Okay, now we're going to see one more example for the generator. What I can do for this? Yeah, how to create generator object without yield keyword. Without yield keyword. If any of the method you are seeing yield keyword, definitely they are going to create a generator object. Okay. Now I'm going to teach you how to create a generator object without a yield keyword. Okay. There is a syntax for this to create a generator object. The expression I'm going to write over here. You have to use the normal brackets in this. The first one will be expression, and then you have to use one for loop for item in whatever you are passing, that should be iterable. Iterable means you can pass list, you can pass dictionary, you can pass sets also, you can pass. Okay, you want to pass some list or dictionary, you can pass some sets also, you can pass your. This is the syntax for creating a generator object. You might be wondering, it looks like a list comprehension. It looks like a list comprehension. If it is a list comprehension, the bracket will be square braces, expression, and then for item in iterable. Iterable means it can be a list, it can be a dictionary, it can be a tuple, anything. Okay, and then you can have some conditions. You can have some condition. Item divided by 2. I'm putting some condition over here. Item I can mention like this: if some conditions. This is a syntax for list comprehension. Don't get confused. If you see some square brackets and you are seeing some expression or for loop inside, and then if condition, you can say it's a list comprehension. You can see the brackets, it's a look like a list. If you see some normal brackets and then you are seeing some expression, then you can assume that we're going to create a generator object without yield keyword. Okay, now I'm going to put on simple example for this expression. What I'm going to do, I'm going to square some numbers. I'm going to square some numbers. How you can square? Apply this syntax and then you can able to do the squaring of numbers. What I'm going to do? Squares generator, the variable name is square generator equal to uses brackets as per syntax, and then first what I have to do? I have to pass the one iterable. It can be a list, it can be a dictionary, anything I can do. What I'm going to do? I'm going to use a for loop. Going to have the iterable variable in. If I want to have one list, I can going to use range function. The range function it's going to return as a list only actually. Okay, I'm going to pass some values 15. Now it will start from 0 to 4 will start, and then every value will be added to this item, and then I want to perform this expression. What I can do? I wanted to square some two numbers, squaring of numbers, squaring of numbers, item into item. If the number is 1, 1 into 1, next number will come 2, 2 into 2, 4, and then next number will be 3, item number will be 3, 3 into 3, 9. Okay, like this I can use this generator object without yield keyword. Look at syntax carefully. If you see some normal brackets and then if you are seeing some expression and then you can see the for loop means, then you can see they are creating some generator object. It's going to have only one element at a time in the memory. It's not going to have all the values in memory. It's going to have only one element in memory at a time. Is with the help of square generator we can do all these things. Now what I'm going to do, see here, I'm going to have one for loop. I'm going to have one iter variable for I in. I'm going to call this generator object. I'm going to call this generator object print of I. You might be wondering, it's going to give all the values. Okay, see here, it's giving all the values 0 to how many values is giving? 196. It takes some small numbers. Instead of 15, what I can do? I can give 5, make n minus 1, 4 into 4, 16. You can able to see squaring of numbers. Okay, where I made a mistake. Hold a minute. Yeah, I use one print statement over here. Generator object without yield keyword. Now you can able to understand. Yeah, you can see. First I will get the item value 0, 0 into 0, 0, and then I will get the 1, 1 into 1, 1, and then finally I'll get, second I will get 2, 2 into 2, 4, and then I will get 3, 3 square will be 9, and then finally I'll get 4, 4 into 4, 16 I'll get. Okay, this is how you can able to create your generator object without yield keyword. Okay, if you want to see the present state, don't go for this for loop. Okay, in for loop you can't be able to see all this step by steps. If you want to see, what you can do? Print of square generator.
List of scores.
What will going to give? It's going to give 0. It's going to give 0. Okay, and then okay, hold a minute. Next, if I call, let's see.
One.
Now let's come 1. Okay, if you call again, it's going to give 4. It works same like yield function, right? But here there is no any keyword of yield over here.
Yield
But
keyword.
you
Okay.
that's no yield keyword. But its syntax is working like this. Okay, you have to use square braces and then you have to use one for loop. Okay, this item is iterable variable, and then every value will pass to the expressions. You can put any expression. I'm putting some simple expressions. You can do some addition, division, subtraction, all kind of arithmetic operations you can able to do. Complex operation also you can able to perform over here, and then you can able to see the state of the your generator, current state of your generator object. Okay, now I'm going to show one more example to you using generator object without yield keyword. Okay, I will say what are the advantages of generators. If you are choosing generators, what are the advantages? The first thing is it's very easy to implement. First thing is very easy to implement, as well as it's very clear and conscious way when compared to the iterators. When compared to the iterators, the iterators, what will happen, it's going to iterate all the values and going to keep all everything in memory. But if you use generator object, it's going to keep only the current state in memory. Okay, until caller calls the method again, it's going to resume that current line, and then the operations will be calculated. Sorry, the performance will, sorry, calculations, the further calculations will be computed. As well as it's very easy to implement. Okay, I want to generate, power of 2. I'm going to have some elements. For every element, I'm going to calculate the power of 2. How we can do? Just take one Py class power. I'm going to calculate the power of 2. Calculate power of 2. Create one method def for defining that function. Power of 2. Okay. In that, I'm going to pass an argument equal to 0. Max value is going to be 0. Now take one more variable, m equal to 0, and then have one while loop, and then check for condition m lesser than maximum. Now you're going to say the while loop is going to run infinite number of times or finite number of times, whether my while loop will break or not. I have one condition m lesser than maximum. I given the maximum value 0, m value 0, whether my while loop will break or not. It will run as a infinite loop. Okay, yeah. Because there won't be any condition, 0 less than 0, there won't be any condition. Okay, the while loop will run infinite number of times. Okay, what you can do, have one yield keyword. In that, what I going to do, I going to calculate the power of 2. If you want to calculate some power, what you have to do, you have to use a 2 asterisks to calculate the powers, and then pass the m value. Now you may be thinking like m value 0, I'm going to get 2 to the power of 0 will be 1. Okay, that's not the output. After yield, what I going to do, n plus equal to sorry, m plus equal to 1. M plus equal to 1. Okay, if someone calls this my method, okay, this yield value will be returned. Yield value returned, this line will be passed. This line will be passed. We're going to see, I'm going to create some generator object, or I'm going to take the variables y equal to power of 2, and then already I given max value equal to 0. Now use print statement and then have next of y. Why it's running next of y, it's giving stop iteration. Okay, next of y, it's showing the line number 8. Next of y, it's running infinite number of times. Right. Okay, I can use for loop for j in power of 2, print of j. It's not printing as it is.
This conference will now be recorded.
See what you have to do, just have one function power of 2, in that have one variable max underscore 1. In max underscore 1, what you can do, just going to pass the value as 5. Okay, and then you have to check for condition 5 less than, sorry, 0 less than 5. The condition is satisfied, then it's going to give this output yield of 2 to the power of m. Now the m value will be 0. Now it's going to give 2 to the power of 0 will be 2 to the power of 0 will be, it's going to give the 1 as output. Okay, this statement will be passed. If the caller calls the method again, what will happen? Statement will be resumed, and then again check for the while loop, and then now the m value will be 1 less than 5, and then it's going to give the yield values 2 to the power of 1. 2 to the power of 1 will be 2 to the power of 1 will be out will be 2. Okay, after giving the output, this statement will pass. If again the caller calls this next of m, it's going to give the range of values. You can use next of m like this, or you can use the for loop to iterate the sequence of values one at a time. Item in power of 2. I'm going to have like 3. Just print item. One print statement using for loop to iterate. You can able to see 1, 2, and 4. Okay, as well as the first advantage is it's very easy to implement, and as well as it's very conscious. Okay, it's very conscious. And then what are things we can say? As well as when compared to iterator, it's very easy to implement. Instead of normal function, we can use yield function to return the current state, as well as without yield keyword also you can able to create a generator object. The second thing is memory efficient. Okay, if you take a normal function, the normal function will return a sequence, will create the entire sequence in memory before returning the result. if I use some return keyword, what will happen, right? It will take the entire element and then it will store the entire element in memory. But if you take generator, it's going to have only one element at a time in memory. It's not going to keep it's not going to have the entire sequence in memory. That is the major advantage to go for the generator object. If we have some return function, the method, that is going to overkill, your memory as well. Okay, if the number of items in the sequence is very large, it's going to take more memory. Okay, in order to make the memory efficient, better go for the generator object, as well as it's very friendly. Okay, instead to have huge sequences, you can have only one sequence at a time. Third thing is, second point is memory efficient. Generator object is memory efficient. Third one is, using generator object, I can represent infinite stream. Infinite stream. Okay. Okay. For example, generators are the excellent mediums, I can say, to represent an infinite stream of data. If you are doing some kind of streamings, or you are reading from the log files, you are streaming from the log files. Okay, I have around 20,000 log files. Okay, 20,000 log files are can't able to keep everything in memory. I want to process the log only one file at a time. If you want to process only one file at a time, better go for the generator functions. Okay, generator functions you can go. And then the last one I want to say, how to generate your pipeline generators. It's very, very important actually. How to generate your pipeline generators. See, we can use multiple generators to perform a pipeline, a series operations. We can use a pipeline series operations. Okay, what I going to do, I going to have two methods. That two methods going to create a generator object. One method is going to generate the Fibonacci series. The second method, what is going to do, it's going to square the Fibonacci series. It's going to square the Fibonacci series. For this, I going to write some methods for pipeline generators. I am going to have one class. This is going to be the last topic, pipeline generators. Now I want to generate the method. Sorry, I want to create a method for a Fibonacci series. If Fibonacci series, in that I'm going to pass argument as number. I'm going to have two variables, chained variables, x value 0 and y value is 1. X value 0 and y value is 1. Now I'm going to use for loop. Okay, you can use while loop as well. Now I'm going to use for loop. Now I'm going to use wildcard now. I'm going to use wildcard. If I put underscore, you have to say it's a wildcard actually. Okay, I'm going to pass the argument as num. If I pass 5, it's going to generate 0, 1, 2, 3, 4. I am not going to store any of the iterable variable. If you want to store an iterable variable, you can give m or n. If you don't need to store in any of the variables, better go for the wildcard. Better go for the wildcard. If you want to store any variables, better you can go for n. Okay, better you can store in one variable called n. But I am not going to store in any of the iterable variables. Better I am going to use one wildcard. Okay. Now, what I am going to do? I am going to have one yield. I'm going to have one yield keyword. In the yield keyword, I'm going to give the values x, and then I'm going to perform some operation x comma y equal to y of x plus y. See, this method is going to create a generator object, and then I'm going to have one more method as well. After generating Fibonacci series, I'm going to square the numbers. I'm going to square the numbers. For that, I can going to have one more method. In the method, I'm going to pass argument as numbers. Okay, I'm going to pass argument as numbers. Now, I'm going to use one more for loop, because whatever the values I'm getting, what I have to do, I want to iterate those values. For that, I'm going to have num in numbers. Okay, num in numbers, and then I'm going to use one more yield keyword, and then I'm going to have this iterable variable into the power of 2. Into the power of 2. This concept actually pipelining generators. Pipelining generators. Now what I going to do? I'm going to have one print statement. In the print statement, first what I'm going to do? I'm going to call this Fibonacci series. Fibonacci series. In Fibonacci series, I'm going to pass the values. The number I want to pass. I want to pass some range, right? I'm going to pass 4. Now what's the value I'm going to get? Okay, hold on. Yeah, I'm going to get. I get the object as generator object I'm getting. Okay, what I going to do? I going to perform the pipelining operation. Pipelining generator I'm going to do. Pipelining means this output is given to the input of square method, right? Again, I'm going to use square method. After performing square, I'm going to perform. I'm going to sum all the numbers. This is how I can do the pipeline generators. One output is given to the another generator function. Okay, and then this output is given to this function. This is called pipelining. If we run this thing, you're going to get the values 6. You're going to get the values 6. Now pass some Fibonacci series value 5. I'll get the value 15. How it's happening here is, now I given the Fibonacci values. Fibonacci values 5, 0, 1, and then 0 plus 1, 1, 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3. Okay, 1, 2, 3, 4. Okay, 3 won't come actually. Okay, because I given 5 the range, right? It is going to generate 0 or 1, and then 0 plus 1, 1 will come, and then 2 will come. I want to square all these numbers. I want to square all these numbers. I want to square all these numbers. 4, 1 square will be 1, and then I'm going to get 6. Sorry, 4 plus 2, 4 plus 1 plus 1. I'm going to get 6, but I'm getting 15 over here. 3 will be 9, 9 plus 6, 15. Okay, understood. Okay, for Fibonacci series, if you give 5, it's going to give 0, 1, 0 plus 1, value will be 1, 1 plus 1 will be 2, 2 plus 1 value will be 3. Now square all these values. 3 square will be 9. 2 square will be 4. 1 square will be 1. Again 1 square will be 1. Finally going to get the value as 15, because after squaring I am summing these values. Okay, that's why I'm getting the value as 15. Okay, what I'm trying to say here is, this is how you can able to perform this pipelining generators. One output is given to the another generator. Okay, another output is given to the another generator. Okay, like this you can able to do the pipelining generators. Okay, if in iterator you can't do all these things, but in generators we can able to perform the pipelining generators. You can pass one output to another generator, another output is part to the one more generator. Like this you can able to perform the calculations. Okay, I'm going to stop the session as of now.